Hi, my name is Tom Brennan, and I'm the technical manager at Sol-Ark. So today we're going to talk about batteries, all about batteries, because they are sometimes the single biggest expense in solar. They don't last as long as panels or the electronics in some cases. So we're going to take a look at different types of batteries. We get these questions often. We're going to take a look at the efficiency, or the round-trip efficiency, or the losses inside of batteries. We'll compare cost per cycle and any sort of restrictions on where to install them. And I think a lot of us are familiar with the standard wet cell, lead acid, gel cells a little bit, AGMs. We'll also briefly talk about nickel iron. The newer batteries that have come out are lithium polymer, lithium ion, or NMC, which is nickel, cobalt, magnesium. And we'll also talk about LFP, which is lithium iron phosphate. And then we'll also talk about carbon AGMs as well, which is one of the newer technologies. We'll talk about battery management systems, which are required on lithium-type batteries. We'll look at some of the warranties, because there is a lot of variation in warranties, and there's some reasons for that. So we'll talk about how to size the battery banks, depth of discharge versus lifespan, and we'll also talk about a feature that we incorporated in the Sol-Ark to reduce our battery size in on-grid and off-grid applications, so that we don't need to spend that much in that aspect. So with that, let's get started, and I encourage you to ask questions on the message board. Okay, first, the traditional batteries. Nickel iron has been around for a long time. The one thing about it is it's pretty big and it's large. It can get a large number of cycles, and we're trying to keep this comparison fair and do a 50% depth of discharge. So, you know, estimates are somewhere around 8,000 cycles for nickel iron. The cost can be pretty high up there because there's a lot of materials, a lot of transport costs. And the other aspect of it is the round trip efficiency is only about 35%. So for every 100% of energy I put in, I only get out about 65% of that energy. But with the numbers of cycles, it can last a long time, and so therefore the cost per cycle is good. Now here's the kicker: because we lose about 35% of the energy on the round trip efficiency of the battery, we have to upsize our array. So let's say we have a 10 kilowatt array. We're going to have to upsize that by 35%. So that the challenge with nickel iron is not in its cost per cycle or longevity. It's really in the opportunity cost or efficiency cost in upsizing the array. So we have to take into account the cost, basically the cost per cycle, then also include the cost of oversizing the array, which can be quite large. Now, when we talk about lead acid, all of the lead acids that we would use in solar are for, solar applications, of course. So these are going to be deep cycle lead acid. That means they're going to be thick plate lead acid batteries, not thin plate, which are more for starting batteries or marine type batteries. With wet cells, we lose about 20% of the energy. They are the lowest cost solution, and they are used quite a bit in terms of low cost off-grid applications because they are inexpensive. They get a fair number of cycles out of the batteries when you take care of them. You have to take care of the terminals and so forth. So the cost per cycle is good. Again, the challenge is that if you're daily cycling these, you're going to have to upsize the array about 20%. AGMs are a little bit more efficient. They only lose about 12%. They cost more than wet cells. Unfortunately, they don't get as many cycles. And the numbers of cycles vary depending upon the manufacturer. And I'll get into a little bit of that. It has to do with how much lead they put in it and how thick the plates are and so forth. So we'll see that a lot of times we want to just look at the weight of the battery, not how many amp hours the battery is. So because they don't get as many cycles, and they're a little more expensive. Their cost per cycle is about twice what lead acid is in terms of wet cells, but they lose less energy. And I'll just make a note about gel cells because they actually get a longer lifespan than AGMs. They've been around longer than AGMs, but the drawback to gels is that you have to charge them at about a 10% rate. That means it's going to take a 10-hour charge cycle, and we don't always have that kind of time. So a gel battery has to be a very large array. Okay, somebody asked, how many years do nickel-iron batteries last at 30% DOD? They're going to last, that's a good question. I don't know the answer. They're going to last, I believe they're going to last longer. You do have to change the electrolyte in nickel-iron batteries every 8 years or so. But I don't have the answer for 30% DOD. And we'll get into DOD versus how many cycles you get out of batteries later. Okay. So I already mentioned this, but there's been a lot of, let's say, different ratings on batteries in terms of amp hours. So I really don't go by amp hours so much as I look at it, but I also compare by weight. That's how much lead's inside. That's how long they're going to last. If you look at industrial batteries, their amp hour ratings are nowhere near what some of the residential batteries are, but their weights are really high. So they're designed to last a lot more cycles. So always look at weight in terms of lead acid. And also some of the technologies, the new technologies that we'll see in carbon. So, if we look at some of, nickel iron and wet cell batteries, the drawbacks are really the round trip efficiency losses. We're losing somewhere between 20 and 35% of the energy. That's just in the battery itself. You also need to account for the fact that we're going to lose somewhere between 7 and 20% in the inverter electronics. So you have to add those two losses. That's getting up there. So you need to take that into account in your application. You also have to vent both nickel iron and wet cells. You'll have to use anti-corrosive spray or delete the terminals. You have challenges with overfilling and underfilling, and if they can freeze if they're discharged. So you need to be aware of that. As far as AGM, the cost per cycle is the biggest drawback. I see a lot more people get more life out of AGMs because they're using it in a standby situation and there's no maintenance. So even though typically you should get more lifespan out of wet cells, often they're not cared for very well, and the lifespan is less than AGMs. So really, if we don't care as much about cycling the batteries every day, because we're going to lose a lot of energy and we're going to have to upsize the array, the wet cells and AGMs, especially AGM with no maintenance, these are good for emergency backup situations. I also have in here another example of AGMs. This is just another manufacturer that has a larger numbers of cycle rate. The cycles that they promote are more ideal scenario situations, and we in the inverter world and real world, we're dealing with various charge rates and discharge rates and peak powers and various temperatures. So we rarely get the ideal numbers of cycles. We have to derate it by about 20%. So, we might see, from another manufacturer a 900, it's spec'd at 1,200 to 1,300 cycles, but we would see about 950 cycles out of it at a 50% depth of discharge. That gets us to only about 2.6 years off grid, and about 7 years on grid, 7 to 8. And because these are a little bit heavier duty, they're more expensive AGMs, and so their cost per cycle really doesn't change that much. Okay, so now let's talk about some of the newer batteries that are out there and compare them to, in this case, I'll compare them to AGMs. So there's a new one out there called carbon AGMs, and again, there's a couple different types of carbon AGMs. There's thin plate and thick plate carbon AGMs. So there's a couple different manufacturers of thin plate. Those are being used in forklifts. They're being used in UPS telecom applications because they can be charged and discharged very quickly. You want the thick plate carbon AGMs because they get more cycles out of the battery. So that's what you really want to look for. The benefits of carbon AGM is low cost. They actually get a fair number of cycles in the real world if they're done properly. Their round trip efficiency can be good, or is good, and it can be improved. We have some special algorithms in the Sol-Ark 8K that gets us, in fact, all these batteries up to about 2% round trip losses. So the numbers of cycles off grid is less than, about 6.5. And on grid, it's going to depend upon the manufacturer and the temperatures that they're stored at. But their cost per cycle can be very good, and their losses of oversizing the array are pretty good. So let's take a look at lithium. Now, lithium polymer, that's what comes in your cell phone. It comes in your iPad. This is really a very low cost but high power density battery. A lot of times they're in pouches. And in terms of, you need to really pay attention because there's 3 different forms of lithium: lithium polymer, lithium ion or NMC, and LFP or lithium iron phosphate. So you want to take a look. I think a lot of people on the lithium polymer and lithium ion, they're really using the lithium name, but they're not really giving you the cycles that LFP provides. And so if you have experienced the lithium polymer, you know how long your battery lasts in your cell phone. It's not a lot of years, maybe about 4 or less actually. So the cost per cycle can be large for that, and it's also the most volatile. Now, lithium ion, this is in quite a few different batteries, and we'll take a look at that. The cost is considerably higher than lithium polymer because the energy density isn't there, but the numbers of cycles double. These are standard cycles. If we look at lab data and a lot of different data out there, 3,000 cycles for NMC is about the average for 50% depth of discharge. And those are under real-world conditions, not necessarily lab ideal conditions. So that gets us to about 8 years of off-grid use, and the cost per cycle is better. It's better than wet cells, or it's close to wet cells, but it's definitely better than AGMs. Where we get a better return on our investment is spending a little bit more money and getting a lithium iron phosphate battery. That gets us to about 6,000 cells, real world, or about 16 years off-grid. And the costs are pretty decent, 28 cents per kilowatt hour, and not much losses, and it's a very safe technology. So I'm just going to focus in on a couple. So if we look at lithium, the drawbacks of lithium are that the BMS reliability, it can be a problem. You need we'll talk in detail about BMSs because that, especially with LFP, with its large number of cycles and long lifespan, that is typically the thing that may fail. You also need to know that lithium, whether it's NMC or LFP, does not like temperatures near 32 degrees. If you get them near 32 degrees, they have temperature sensors, and the challenge there is that you often void the warranties, and also you can, if you let the battery freeze and you charge it while freezing or near 32 degrees, that 6,000 or 3,000 cycle battery can have as few as maybe 100 or so cycles of charge cycles. So you really need to be careful about low temperatures. So LFP works really, really well at places like islands, like Puerto Rico and Hawaii and some of the southern states. other places, you need to be careful on where you install these batteries. As far as carbon AGMs, they don't have the temperature issues as much. You know, they're pretty okay. The thing is, they're more susceptible to heat because that will reduce their numbers of on-grid years. So it can kind of age the battery quicker than it can a lithium battery. So you need to be more sensitive about where you install them for heat purposes on carbon or AGMs in general. The one other drawback to these carbon AGMs is that there is no BMS, so you can over discharge them. We're going to get into charge and discharge, depth of discharge and numbers of cycles, but it's very, very easy to over discharge them, especially if you're off grid. So in our case, we try and use the inverter as a BMS because there's no BMS in the AGM battery. Okay, so someone asked the question, if the PCCs were at a temp of minus 15 degrees C, could I take them down to 40 to 50% DOD and not have to worry? I believe so. I don't think they're not as sensitive to cold. Their capacity will drop, as all lead batteries will, but they don't get damaged. The lithium also reduces its capacity as it gets near cold temperatures, but if you get it near freezing, it can damage, which is why there are some manufacturers out there that are starting to heat up their batteries for lithium. Okay, so with that, and by the way, feel free to ask questions as we go through on the message board. So let's talk about the BMS, because this is one of the differentiating factors on batteries. It is effectively required for balancing the cells. If you're dealing with lithium iron phosphate, you definitely need it because those cells will, over time, charge and discharge cycles, they will become unbalanced if they don't have a way to equalize out the power in the cells. If you get one of these cells really, really low, then because they're all in series, then that will be your weakest link and will be the limit on how much power you get in and out of the battery. So that's why they balance the cells. The other benefit of having a BMS is it really protects this investment that you've made in batteries from overcharging, over discharging, and shorts, and that in turn prevents a thermal runaway condition. Also, we use the inverter to help out in this scenario so that we don't push it to the extremes. So the other thing, I should say, an NMC battery, balancing the cells is a good idea. However, NMC is not as susceptible to becoming unequal as much as LFP. So you may be able to get away with not using a BMS in an NMC situation. So a lot of people are trying to use car batteries. So anyway, it's a good idea to have a BMS. It's very, very safe. I recommend it, but it's not necessarily as required as much. The other part of it is a BMS is really good for doing a couple other things. It can very accurately measure your percent SOC. It also keeps track of temperature, which you want to do for safety reasons, and it's a good way to communicate to the inverter so that I can do remote monitoring. Okay, so let's take a look at the different types of BMSs, battery management systems. There's really just two basic types, an active, which is MOSFET-based, and a passive, which is more relay-based. The MOSFET-based is, you'll see some MOSFETs here. Here's the balancing, and each one of these goes to the cells. This is just an example. But these MOSFETs, these are acting like a switch. So these can be damaged by the inverter, especially like when we first connect up the inverter, where we have to charge very large caps in an inverter situation. So that can be damaged that way. Also, we can damage them with ESD. There's also the challenge of very large peak currents in inverters, battery-based inverters. So a lot of the BMSs that we've seen can shut down due to those peak currents, and then your power goes out, and you have to figure out what happened. Maybe my BMS wasn't large. Oh, somebody asked, what is ESD? ESD is electrostatic discharge. That's when you're in wintertime, you're going across the carpet, you shock everything. So that's ESD. I've seen BMSs fail just due to ESD. Not all the BMSs are bad, and because there's a few that are built well that are MOSFET based, and you just have to do your research. So these are just some of the challenges with a MOSFET based BMS. And I have seen, like I said, I have seen some good ones. I'm more of preference of a passive relay based BMS because it replaces all these FETs with a relay. It's very reliable. So it is more costly, but you don't have as much to go bad. Some things that you should look for in a good lithium BMS are what's its continuous amps. I like to see somewhere between 150 to 200 amps. Surge amps of maybe 500 amps for 5 seconds or so, and peak amps up to maybe 1,000 amps. You also, because inverters have capacitors, you want to look for a pre-charge that will slowly charge up the caps and not just hit it with 3,000 or 5,000 amps when you first turn on the battery. You also want to look for ESD testing. And it's very nice if the manufacturer's done some highly accelerated life testing at high temperatures and high humidity to verify that your BMS is going to last as long or longer than your cells. Okay, so with that, let's talk a little bit about warranties, because this is where it really gets interesting. There's been a lot of activity in warranties on batteries that has us scratching our heads. So first, let's take a look at the LG Chem battery. And this battery, which is, it's nice because it can be actually installed outside or inside. It is used for StorEdge. It's used for the SunnyBoy storage, and it's used for Huawei. So it is a 380 volt battery externally, but it's 50 volts internal. So let's just see some of the specs. First of all, it's the battery total capacity is 9.8 kilowatt hours, and you can use about 9.3. And if you go to have this installed, and this is not including installation, but an installer would charge probably somewhere around $7,000 for each of these batteries. And I just want to reiterate again that NMC chemistry, by and large, gets about 3,000 cycles at a 50% depth of discharge under real-world conditions. So I admire LG for being honest about their lithium and how long it will really last. See, in some places they mention that their warranty covers about 3,180 cycles, which is very close to this 3,000 cycles. However, they count a cycle as even a 10% discharge. So, but anyway, they provide a 10-year warranty, and that the capacity of this battery will have 60% of its remaining capacity of this 9.3 after 10 years of use. However, when we look at the warranty, again, they're honest about all this, is that the warranty after year, let's see, this is year 7. So after year 6 or after year 7, this basically your compensation if the battery goes bad is just drops off a cliff. And that's because they're effectively saying this battery lasts for 6 to 7 years. And their warranty shows it, and they're honest about it. So I respect them for that. What is a little bit challenging is that their battery is 380 volts externally and 50 volts internally. So they use DC to DC inverters to go from the 380 volts to 50 volts and back up. And they show their efficiency of their DC to DCs as 94.5%. So if we go in the battery and out of the battery, excluding the inverter and the actual NMC chemistry, we lose 11% just to the electronics of the DC to DCs. So that's the challenge with this battery. Is there's significant round trip losses similar to things like a standard AGM battery. By the way, if there's any questions, feel free to ask. Okay, so here's just another example. This is a Darfon, several different Darfon batteries, because I just wanted to point this out. I don't really have price and warranty information here, but what I wanted to show you is they started out with an NMC battery, and they show about 2,500 cycles, and this again, I'm not trying to ding them on saying that this is 80% depth of discharge at 25C. That's not really real world conditions, because our temperatures change and we're not using standard constant charge and discharge rates, so we really wouldn't see this many cycles under normal operating conditions. We'd see more like 3,000 cycles with the 50% DOD. But what is interesting is that they realized that NMC is not, it has a lithium name, it has a lithium price, but it doesn't have a lithium longevity. So they switched to, they also offer LFP, which is far better in terms of cycling for solar applications, and it's safer. So I just want to point that out. And also they're saying, hey, don't get it below 0 degrees C or 32 Fahrenheit. So they're just reconfirming, the numbers of cycles for LFP versus NMC, and it's about double. Okay, so let's talk about Sonnen, very famous in the battery world. They have the Eco 16, which is a 16 kilowatt. Now they have different variations, but I just chose a 16 kilowatts because I would like a large battery if I'm using it. Theirs is LFP, which is a very good technology for cycling. Their MSRP, their MSRP price, manufacturer suggested retail price, is $24,000, and that includes a radiant inverter. Gosh, I hope I didn't copy that throughout the slides. So now here's the challenge with the battery. It's not in its warranty. The warranty's great. They warranty this for a flat 10 years. And what's even more impressive is Outback only warranties their electronics for 5 years, including the radiant inverter that's inside here. But Sonnen actually warranties the inverter, the Outback, for 10 years. So the entire thing is 10 years. That brings me back to why are the warranties stretched out to 10 years? I forgot to go back to that. This 10-year warranty cycle started back in California because California was offering some incentives. They still are offering some incentives. I'm not sure what they are at this time, but they were offering incentives for battery-based storage if you had a 10-year warranty on the battery. So manufacturers like LG offered a 10-year warranty that was heavily prorated just so they could make that rebate program. And that's how we got started on the 10-year warranty cycle. Okay, a question here. Are you familiar with standard for testing performance of batteries? Note the IEC is a European business. If you've heard of it, do you know of any battery manufacturers that are testing to this standard? I am familiar with some standardized testing for batteries. I believe Trojan uses them on some of their wet cells, but I don't have some of that data here. So there are, what somebody's mentioning is there are some standards for testing of the performance of batteries, which is good. We need some more standards on batteries because we're kind of all over the place. Yeah, and we'll see it even more. Here, the one drawback I see to the Sonnen is its AC coupling losses, Because they only AC couple, we have 3% lost in the string inverter. So this is going from PV to battery to, and then out of the inverter. So we lose 3% to the string inverter. The radiant charger to the battery is 85% efficient, so we lose 15% there. Then we lose about 7% come out of the battery for the inverter loss, and so we lose about 25% of our solar energy, AC coupling in and out of this battery. And it's not really the battery technology. It's kind of the inverter. So, but anyway, a very nice warranty. Again, 10 years. And I believe that was also stretched. Their battery technologies can certainly do it more than 10 years. They really wanted to, that was probably the California warranty, or the rebate program again. Okay, so let's take a look at Relion. And what an impressive name. It's pretty cool. So this is an LFP battery. And this is the case. It's about a 15.4 kilowatt hour, 51 volt battery, 300 amp hours. It sells for about $13,000. The BMS is a decent sized BMS of 200 amps, and it can do a 4-second surge of 250 amps. So we would, on surging, we would trip the BMS on this, on the 8K, because we can surge to about 400 amps. But the warranty is a respectable warranty. It is a realistic warranty where it's 3 years flat, and then you get another 4 years prorated. That's where we used to be, and so that's a respectable warranty. Some interesting things, always read the fine print. You're spending a lot of money on this battery. You need to look through the fine print before you purchase. On this one, it's kind of interesting. Product. The warranty, you can void the warranty if the product was undersized for the application. So beware. Now, what is also interesting from Relion is some of their marketing, their brochures. This is a chart from one of their brochures, and if we look at the 50% depth of discharge, it almost shows a linear curve to about 50% of the remaining capacity after 23,000 cycles or 64 years of use. Does it last that long? No. This curve does not do this. It looks very, very different than this. This is an extrapolation. It's so there's like I said, the warranties and some of the marketing of lithium is all over the place. If this lasted 64 years, why would the warranty be only 7 years? So, there's some real world data out there that shows it's about 6,000 cycles at 50% depth of discharge. Okay, so now let's take a look at some different technologies. Now this is Panasonic, which is used by Pika. It's a 20 kilowatt hour battery, but it's NMC. So it's lithium ion, and I misspelled this all over the place. The price is about $15K. Again, like LG, they use externally. The Pika and the battery are 380 volts DC, but the battery really inside is 50 volts and has up to 6 of these. So they're a little bit more efficient. They're about 96.5% efficient on their DC to DCs, but you can still see a lot of energy is wasted. About 7% of the energy is wasted in round trip efficiency, and that's why they need these big fans. Let's see. Some other challenges are you cannot change the battery in the inverter setup. You have to call up the factory to do that, so you can't really. If you're in a dire need and you need to use some more capacity in the battery, you really don't have that ability. So the nice things, it's got a 10-year warranty. Interesting enough, you have to connect it to the internet or it voids the warranty. So you should ask, I guess I wonder, why must it always be connected to the internet? I don't know. I think it's to make sure that the battery lasts to 10 years. So they want to monitor that. So how are they delivering 10 years? of performance out of an NMC battery that would normally just be about 8 years? You know, are they doing some things like maybe Apple that reduces the capacity of the battery to extend the life? And I really doubt that. It's really probably because they upsize the battery. The usable capacity of this battery is only 15.9, so they only allow you to be able to use up to 78% of the battery. So they upsize the battery by 22%. So that's how they're extending the life, most likely. Or that's definitely extending the life. I can't comment on whether they changed the capacity of the battery over time. Okay, so now let's talk about Tesla. This is also a lithium-ion NMC battery, and NMC is inherently inferior to LFP. So for cycling usage in solar. So they require us to purchase 2 batteries. You can't just get one anymore. So it's a 28 kilowatt hour battery, and they don't upsize the battery much. Only about 27 kilowatts is usable. The MSRP price is about $7,000 per battery, and they suggest somewhere about $4,000 to $5,000 for an install. So this battery bank would cost about $19,000. However, a lot of quotes that we see are up there, somewhere around $25,000. Maybe they're charging more for installation because the battery is in very short supply. One of the benefits of the Tesla battery is it's got built-in inverters, 10 kW continuous with 2 batteries and 14 kW peak. And they warranty the battery for 10 years. It'll be 70% of the capacity. Again, they're interesting. They're trying to make sure NMC lasts. So you have to connect it to the internet, or actually the inverter shuts down. And this has happened to some of the installers. After 48 hours, the battery will shut down. And they called Tesla and they said, well, we'll issue a firmware update if we see an emergency coming, you know, something like a hurricane. So that's nice. But really the big question is, how are they delivering the 10 years? They haven't upsized the battery. So how are they delivering 10 years out of an NMC battery that really, whose life cycle is about 8 years? Some installers have asked, well, why is the past, you know, they have detailed usage data, but, you know, after you get past a certain point, it gets erased. So why is some of the past data erased? They're not quite sure. And why must it always be connected to the internet? So some installers are questioning, you know, are they reducing the capacity of the battery over time to extend the life? You know, some examples like Apple. So I don't know. Okay, so getting out of lithium, let's take a look at some carbon AGM type batteries. And here's just an example, Outback EnergyCell, and this is a 200 pure lead carbon AGM. If we take each of these is 178 amp hours, and if we multiply that times 4, we're about 8.5 kilowatt hours. MSRP price, about 2.6K. Also, look at the weight, because you always want to look at weight when you're looking at lead acid batteries. Now, if we look here for 50% depth of discharge, we're getting about 3,000 cycles. Again, I would say we need to derate that about 20% for non-ideal real-world conditions, so about 2,400 cycles. It is a thick plate carbon AGM, so it handles cycling well, and it also does partial state of charge well. It doesn't sulfate up the battery, and that's how come they can get a lot more cycles out of it. Now, it has an impressive 6-year warranty that it will have that capacity after 70%. However, there's some fine details on voiding the warranty. So if you get your battery hot, you know, the average temperature is over 86 degrees Fahrenheit for 30 days, it's aging the battery, and you know that'll void the warranty. Not sure how they'd prove that though. But anyway, because there's no temperature monitors on this side, but maybe you could look through the inverter. The other thing is, now this is what's interesting. It also voids the warranty if you discharge the battery lower than 12.3 volts, which is really only a 35% depth of discharge. That's somewhere around 4,500 or 5,000 cycles. So that's kind of interesting. They don't let you cycle the battery much if you want your 6-year warranty. Wow, not a lot of questions. So Sol-Ark, we're introducing. We already have the PCC 200 battery, which is 4 batteries is about 8.5 kilowatt hours and about 2K. It is a partially charged carbon AGM, but we're introducing a PCC 250, which is a 250 amp hour battery. It'll give us 12 kilowatt hours, MSRP price of 2.5K, and it weighs 180 pounds. So it's definitely a 2-person lift. And we expect to get about 2,400 real-world cycles, because that's where carbon AGMs are about in technology these days, if we do them right. And again, it'll handle partial state of charge. So this will be available in May of 2019. We just go with a flat warranty of 3 years. No need to do anything differently. You will get a long lifespan if we use the inverter and program it correctly and use it as our BMS, and it will extend the life a very long time. So, a couple questions. Can we add a bank of 250s to an existing bank of 200s? Of course. They're the same battery technology. Some other questions. Perfect for off-grid 3 or 4 times a year, a few days at a time. 3 or 4 times a year. Oh, yeah. Carbon AGMs, we'll get to a summary, but AGMs or carbon AGMs are really good for a few days of the year. And what do you mean when you say a manufacturer has upsized the battery? I'll try and get to that. I'm saying when I say upsize the battery, I'm talking about you can see, and I shouldn't use Outback as an example. They're reputable. When we can see different amp hour ratings for the same weight battery all over the place. So you really should look at weight, because if you see a 300 amp hour battery that weighs 130 pounds, it's not true. So anyway. Okay, some other questions. Is there any way to use these batteries with existing Sunny Island inverters? Yes. I believe if they're 48 volts, then yes, you can use it with a Sunny Island inverter. Do you recommend an enclosure? For 48 volt batteries, I don't really think you need an enclosure, and they're also stackable. You can, I mean, for example, you really don't need this case even. You can actually take these batteries and stack them on top of them. You can do one on top of the other. It's a nice 2-foot by 2-foot cube, but so they're pretty flexible. For higher capacity, how many strings can we be used? We'll go into that. We can do up to 4 strings. Oh, our inspector wants them enclosed. Well, then you can do an enclosure. Okay. Do they interlock when stacked? No, we use, so there are different, there are some battery racks out there. We offer a battery rack that goes up to 16 batteries or 4 strings. Okay. So any questions that I may have missed? Okay, I think for earthquake prep, then use a rack. Yes, they can be bolted to the ground. So there are some racks that are earthquake proof or earthquake proof to a level, and so you can use a rack there too. A lot of times I just put them on the ground though. Okay, so I just want to summarize here. If we compare the different technologies, you know, of lead acid and lithium batteries, wet cells, AGMs, and carbon AGMs are all good for emergency backup because they're all fairly low cost. I would say in terms of lithium, you really want to look at LFP batteries because of the this is if you're going to cycle them every day. And if we were to cycle them, we're getting down to about a quarter per kilowatt hour. Yeah, kilowatt hour, yes. About a quarter or 28 cents per kilowatt hour on cycling on the battery, and not very much losses. The other battery that is also a good choice, or can be a good choice, is carbon AGMs, and it can be as low as about 18 cents per kilowatt hour. So it makes it also good for daily cycling. Both of these are good choices. So when we look at the way things are going in the United States and other places, we're losing net metering, and we're having to use solar during the day and use batteries at night to do self-consumption, because they're going to charge us a lot. They're not paying us very much for our solar power, and then they're charging 20 cents or 30 cents or more per kilowatt hour in the evenings, changing the rates. So if your power in the evening times is 20 cents per kilowatt hour or maybe 30 cents per kilowatt hour, then these solutions make sense. If you have a good net metering agreement, and then you don't need to cycle your batteries every day, and you can just use an emergency backup battery. You don't need to spend so much on expensive batteries. So the choice is up to you. Okay, but keep in mind, no matter what battery choice you make, my preference is, go with something that doesn't have a lot of loss. If it's emergency backup, it really doesn't matter because you're not cycling it all the time, so you don't have to upsize the PV array. But whatever your losses are in terms of round-trip losses in the battery, you need to add that to the round-trip losses of the inverter. So whatever inverter solution that is. Sonnen, we've already included it here, and Tesla's included. So anyway, just add whatever the losses there, so that you can lose about 10% of when you include the battery, about 10% of the solar array using those batteries versus some of the other solutions. And again, it may not necessarily be the inverter. It may be the battery DC to DCs that are causing this loss to be so high. Okay, so in terms of sizing the batteries, whether it's lithium or whether it's AGMs, now in this case we're talking about carbon AGMs, the numbers of cycles will depend upon the depth of discharge. So I showed you that rely on, but anyway, so we have an online sizing tool that can help you customize a system. You're really sizing the batteries for what you want to power at nighttime, and whether you're on-grid or off-grid. So if we talk about just emergency backup applications, we're rarely going to cycle the batteries, so we can go to 80% depth of discharge and do, almost 950 cycles. So typically a 12 kilowatt hour battery bank is going to be fine. Maybe you have a lot of appliances that you want to run, and you might need a large capacity battery bank, but this is emergency backup. If we're dealing with time of use applications, we're going to cycle that battery every day, about maybe up to 50% depth of discharge. We'll get about 7 years out of it. And then also it'll be discharged a little bit more when we use it for emergency backup. And so there we want to upsize the battery, maybe somewhere between 24 and 36 kilowatt hours. And then if we're off-grid, we really want to try and target a 30% depth of discharge so that we can go multiple days without losing our batteries. This way we'll get about 10 years out of them, and we also have a generator's backup. So that's where we tend to go large on the strings. And keep in mind, most of the appliances in our home don't use much battery. A freezer is about half a kilowatt hour. A fridge is about a kilowatt hour overnight. Lights use almost nothing these days. Fans, for 12 hours use of ceiling fans, is only 1 kilowatt hour. It's really when we get to the big things like if I have natural gas or propane heat and I have a furnace fan I need to run, that's about 7 kilowatt hours. And that's a good thing to back up. You don't want to lose heat. So in the wintertime. Air conditioning, that's a bit more challenging. It tends to be about a kilowatt hour per 1,000 BTUs. So there you're talking more batteries. Okay, question here. Can you use a 120 volt generator for backup generator to charge batteries with the Sol-Ark 8K? Presently, no, that we would use a transformer from 120 to 240, so we only support 240 now. We are investigating if we could do a 120 volt generator for charging batteries on it with the generator at 120 volts. Yes, we can do 240 in terms of charging the batteries currently. Okay. All right. So one of the ways that we reduce the battery bank size on the 8K is a smart load. And, you know, it shows up in the screen as smart. It's adding, it's an additional breaker output. It's 120/240. It's a 40 amp breaker. And what it does is when our batteries are nearly charged, and we can certainly program them, it turns on additional loads for us. So effectively, that's when the solars come up, and it's charging the batteries. And then once the batteries are getting full, now I've got a lot of excess solar power. So I'm wanting to turn on additional appliances, things like an electric heater, or maybe an electric hot water heater, or maybe one of these new hybrid heat pump hot water heaters, which are 4 times more efficient than electric hot water heaters, or maybe a dehumidifier, or maybe a heat pump or air conditioner. Split units work great. So this smart load capability does automatic load control for us, and it allows us to, once we get the batteries back up to where we want, it will turn on these loads, these additional loads, and those switches, and it will turn off if we start to use up the battery too much. And also it works for time of use. When we're on the grid, I can set it to where the solar panels are producing enough power. It turns them on even when we're on the grid. It doesn't necessarily depend upon the state of charge of the batteries. So this really helps us to reduce, put some of the large appliances that we would normally need on running from PV power, not necessarily battery power. So we don't have to size our battery bank, and we're not cycling the battery so hard when we can put these big appliances on when the sun is producing. Okay, so that's what I wanted to cover. You know, we've got some future webinars, like we'll cover some details in the touchscreen menus and in terms of every function and how it works. We'll talk about the we'll do a webinar on the Wi-Fi setup and registration and phone apps. We'll talk about net metering, how it's going away, and how we use that limited home mode and smart load. We'll also talk about optimizers, shading and angles and monitoring and compatibility, and also rapid shutdown. So this will actually show some live data. And let's see, we'll do some more comparisons. We'll also do the customer sizing tool that I mentioned earlier, and we'll talk a little bit about standby generators versus a solar UPS. And you're more than welcome to contact us and give us suggestions on what else you would like to see. So with that, I want to thank you. And if there's any questions, please ask. We'll do some future webinars. Not sure on the dates yet because we've been doing about 2 a month. Quick question, does the inverter allow for critical load prioritization? Okay, so in terms of the critical loads on the 8K, we call those the UPS loads. The critical loads will always be powered. There is no prioritization. It will power them all. It is the smart load that is really prioritized, and it's just an optional load. And we tend to put the big things on that. So I hope this has been interesting and a learning experience. And you're welcome to call us or email us and ask questions. But I really hope you learned. So any other questions I can answer for you, I'll stay on the line for a few minutes. And please ask it via messages. Where do we get a copy of this video? Okay, we will put it up on our YouTube channel hopefully by Friday. And you're welcome to share it. We want you to get the batteries are a very big investment. You want to get the most you can out of them. I need help finding a battery box. Okay. All right. Well, anyway, I really appreciate your time, and thank you very much.